Alrighty, welcome back. This is our third lesson in our radicals unit, and we'll talk about multiplying and dividing. After this one, it takes a little bit of a turn where we get into some of the things with variables and what we can do with if there's a variable in that radicand and solving equations and that sort of thing. But we need these operations here first. So multiplying and dividing is what we'll talk about. So if we think about multiplying, it's very similar, again, to polynomials. So as long as we remember what happens to those, we can translate that into what happens with radicals. So think about A there. We've got two things in those brackets, right? 3x is one of them, 2y is another. And one of the things people want to do, and what they want to try here, is to do something that looks like this, and they try to use what's called the distributive property here. But that only works if you have multiple terms inside your brackets. I don't, and it looks like I have different things, but just remember that 3x is that one item. There's no positive or negative sign in between the coefficient and the variable. So in other words, that is not the same thing as 3 plus x times 2 plus y. In that case, I would use what we call the distributive property to do this. But with the example we actually have, those aren't the same thing, so I can't. Okay, they're very different. So here, what you would do is actually the easier of the two cases. Multiply your coefficients together for 6, multiply your variables together for x, y. That's all there is to it. You're done. So when we think about this, just remember that if there's no positive or negative sign in between the coefficient and variable, really you're just multiplying everything together. So this is the same thing as saying 3 times x times 2 times y, right? Everything's getting multiplied for 6xy's. If you think about b, the logic is the same except dividing. So we're going to divide the coefficients and then divide the variables. 10 divide 5, you'll get 2. Now x squared divided by x. We saw this in the previous course in Math 10 that said if you had the same bases, top and bottom in a fraction, you could subtract your exponents, you'll end up with x. And the reason why is because, well, x squared is just x times x, and you've got your 1x on the bottom. So when you divide them, one of the x's on top cancels with one on the bottom. You're only left with x to the power of 1, which is where you see it in the answer. So there you go. If you think about c, well, now I've got a coefficient of 2 on the outside of that set of brackets, and that's an x plus 6. This is the case where you could use that distributive property, right? Two groups of x plus 6. You have two of them. So in total, you have 2x's plus 12 if you double everything in that set of brackets. So same rules like you saw before, just a little bit recall there to get them in the front of your mind. And underneath here, it's a good spot to come back to because it has a lot of information, but it's very overwhelming to read it all. Now the two parts that are important here are these top two bullets really. So when it says when we're going to multiply and divide, work the same way as polynomials. So perform the operation to the coefficients, right, to the numbers on the outside, then perform the operation to the radicands. And whatever happens to the radicands, they stay under a root sign. That root sign only goes away if you end up with a number that's a perfect square or something like that to make it actually disappear and cancel. So the information there is good. It gives you some examples, but it's kind of complicated because it's got some variables and stuff. It's just a general rule. So we'll talk about a few examples, and it does make it easier to think about it in terms of numbers. So we'll multiply these, and then we'll simplify them if we can. The simplest mixed radical possible. Okay, so our rule there, we said take your coefficients, multiply them. So 5 and 2 get multiplied together for 10. Your root sign will stay for now, and our radicands will go together for 63, right? 3 times 21 is 63. But now see if you can simplify this just like we've done in the past. And 63 is 9 times 7, which means we can square root each of those numbers and multiply them together, because that's what it means to actually multiply. Think about actually going backwards, right? 9 times 7 is our root 63. So it does work. We just don't really talk about that rule till right here. Okay, so there's my 3, there's my root 7. 10 times 3 for 30, root 7s. simplified perfectly. And radicals, again, is a nice unit because you can check it to make sure you're right. So I'll put in the original, 5 square root 3's, multiply it by 2 root 21's. There's the decimal I should get. So let's do 30 root 7. Make sure our number's the same. We've done it perfectly. So your calculator is very helpful in double checking. Just try not to leave your answer again as a decimal. We talked about that before. So we'll leave it as an exact value here. Okay, you can think about b as well. It's very similar. Right, your coefficients get multiplied. So coefficients make 6. Radicands are 12 and 2. They make 24 when you multiply. Simplify. 4 times 6. 4 comes out. It's a perfect square. Right, we're choosing them that way deliberately. So 6 times 2 times root 6. You are left with not 8. I just added them. So 12 square root 6's. Right? 6 times 2 is 12. Okay, so there you go. Again, multiply and express the product as a mixed radical. Again, simplest form. So I'm going to leave a and b. You can try them out using what we talked about above in that first example. So try them. The solution will be given to you. Right, I'll have that key in the links just like all of the other videos do. But let's think about one that's more complicated. Right, we talked about distributive property. The same thing is true here. Now, you can only really separate those terms with an addition or subtraction sign. So the radical on the outside, think about it as one combined item. And that's what we're going to distribute to the inside. And on the inside of that set of brackets, there's another radical with the coefficient, but again, treat that as one thing. Don't try to split up the coefficients and the radical, because it won't do mathematically what you want. Right? I only have 2 terms in the brackets. I'm going to multiply in 2 places only. There's only 2 terms, and they're separated by that subtraction sign. So my first one, I'm going to end up with, maybe I'll color code those arrows. That might make it easier. So we'll do a red one, and we'll do a pink one for the back. Okay, so for our red arrow, when I multiply the radicals together, you're going to get a 6 square root 4. The pink one will leave you with a minus 15 for the 3 times that negative 5. But when you do your radical, there's no radical you're multiplying with, so it just stays. Right? Essentially, this is 5 times the square root of 1, because the square root of 1 is just 1. Right? We don't usually see it there. So there we go, my radical will just stay. But now I can try to simplify. Square root of 4 is 2, so 6 times 2 will give you 12. And I've got a minus 15 root 2. I can't put that together and make it any simpler, so there it is. Okay, I can't do my root 2 any further. Okay. B is very much so the same, except now there's 2 terms in each set of brackets. So if you've heard about FOIL in the past, the same thing is true here. So we'll do 4 different colors, because I'm going to have 4 different terms. And again, those radicals are not 2 parts. Take the coefficient and the radical as one. Okay, so there's my 4 things I'm going to have. So green one says take the 2 radicals, multiply them. 2 times 3 for 6. Again, root 4. That's nice. So I know that will simplify. Orange one next. But the order doesn't matter. As long as you have all 4 of these arrows, the order you do them doesn't matter. Okay, so the last term there, minus 4 root 2's. Blue one will get you 3 root 2 because you're multiplying by 1. And red one for minus 2. Now you can only put together the things that have like radicals again, so same index, same root sign, or same radicand I should say. So simplify everything you can first. So 6 times root 4. Well, root 4 is 2. 6 times 2 is 12. So there's a 12. We'll do it one step at a time. So nothing else will change just yet. Now I've got some constants that can go together and some root signs that can go together. So we're going to have 10 minus root 2's. Because the negative 4 as one coefficient, positive 3, it'll reduce to just having negative 1 left, and root 2. So there's my simplified expression. So it looks good. So we talked about multiplying. I'll leave again A and B here so you can try it on your own, make sure you know what's going on and check the answers. But let's talk about dividing. Now there's one thing with dividing that causes a problem. We're not really going to want to leave our final answer with a root sign in the denominator. Okay, it's something we're going to have to deal with and make go away. For the same reason we don't like seeing a negative sign in the bottom of a fraction. It just is the notation thing that just looks weird. Mathematically, it's not wrong. It's just less correct on the basis of notation. So we got to make it go away. So we'll talk about that here too. So if we can divide. My coefficients here are both 1. Right? There are imaginary ones that are on the outside. So a 1 divided by 1 is just 1. So that's good. Now I can divide my radicands. So they're square roots, which is good. So 54 divided by 2 gives you 27. So since they actually divide with each other, that's nice. And I can actually just divide them. They stay under a root sign. And then simplify if possible. So turn it into a mixed radical. 9 times 3, which really is the same thing as 3 root 3. You can square root the 9. It becomes your coefficient. Your other number of 3 stays underneath. So that was pretty good. The problem is, well, for B, they don't divide nicely. So you can try to do 18 divided by 25, and it leaves you with a fraction, or a decimal, right? It's not a nice one to actually divide. But if you look at 25 and recognize that, hey, that's actually a perfect square number, so I'm just going to take the square root of it, works out to be 5. Root sign gone. So that's good. I didn't have to divide them. There's no root sign in the bottom. So that's excellent. Now you got to simplify the top. Well, 18 is 9 times 2. That's divided by a 5. 9's a perfect square. So if you square root it, it ends up as your coefficient for 3. Root 2 on top. Divide 5. I can't simplify this or reduce it any further. My coefficients are already in lowest terms. You're done. Okay, you are done right there. So we'll do these two together because I know dividing, especially fractions, causes a problem for a lot of people. So we're going to talk about that maybe I don't realize that 40 and 8 are actually divisible. What if I don't recognize that I can actually divide them and I don't put it in my calculator to check? Now one of the things you can do, it's called rationalizing the denominator. So we'll do this one two ways. Denominator. And essentially all that means is we're just going to get rid of the root sign that's on the bottom. That's all it means. Now I can't just erase it to make it go away. I actually have to do something to make it cancel. One of the things you can do in math that doesn't change the value of anything, you can always multiply by 1. Now that 1 is going to take a very specific form for us, and it's always going to come from what's on the bottom of your fraction, right? The root sign on the bottom. That's really our problem, right? So I'm going to multiply the bottom by the square root of 8, but what if I do that to the bottom? I also have to do that to the top, so the value is the same. Right? I don't want to change what this fraction's worth, because then I'm changing the expression. But root 8 divided by root 8 is just 1, so I'm not changing the value because I'm multiplying by 1, right? That doesn't change. So if you think about multiplying these together, actually maybe what I'll do is I'm going to write it on the bottom. So I'm going to copy this, put it here. Oh, it doesn't take the picture? That's unfortunate. Okay, let me just rewrite it. Give me 1 second here. Okay. So square root 40 over square root 8, and we're going to multiply the top and bottom by root 8, essentially multiplying by 1. So what happens to this is the bottom becomes square root 64, but the top becomes the square root of 320, right? 40 times 8 if you use our multiply rules. Now, look at the bottom part. If you think about the number of 64, well, it's a perfect square number. So when you take the square root of it, you get 8. A root sign disappears, and you're always going to see that denominator number in 3 places. The original question, what you multiply by, and the result you get, right? They're all going to be the same, no matter what, every time. That's a very, very useful to make sure that things work the way they're supposed to. But now you got to think about the top part, right? 320, well, that's a perfect square. Or no, sorry, 320 is not a perfect square. We're looking for a perfect square factor inside of 320. And if I divide it by 5, I'm going to get 64. So 64 times 5 is what happens inside. And you can reduce that and simplify it, because you can take the square root of 64, write it outside. So 8 root 5 divided by 8. And if you notice, you have an 8 on the top and the bottom. They cancel with each other, and you are just left with the square root of 5. So this will work to help simplify it. And it's helpful if those two numbers that are your radicands don't divide with each other right off the bat. With this one, however, if you recognize that 40 divided by 8 is 5, so here's the original question again. If you just divide them, 40 and 8, you get 5. So the rationalizing version of this solution is a little bit longer, but it does do the same thing. The problem is division doesn't always work. It doesn't always work. So sometimes you will have to do that longer way, depending on the original question. So we'll do one of those together in this video as well. So if you look at B, we'll do that one too. But we can't, we won't rationalize this one because if you look at the radicands of 30 and 5, well, they're going to divide each other nicely, and you get 6. Okay, so this one will work. So we got to think about dividing our coefficients here first. One's a 6, one's a 24. It doesn't work perfectly, but I can reduce them to lowest terms. So if you divide the top and the bottom by the same number, again, you're not changing the value, so we'll divide the top by 6 and also the bottom by 6. So that'll leave you with root 30 on top over 4 root 5s. Okay, that'll reduce nicely. And then if you divide your radicands, you're going to be left with square root 6. So I've got a square root 6 divide 4. And I'm done. And I'm done. Right, I've divided, and I know that my root 6 is going to go to the top part, because really I could take this and split it up, and you can think about your coefficients being multiplied with your radicals. So 1 over 4 multiplies with root 30 over root 5, which when you simplify, right, your root 30 over root 5 turns into root 6 that you're multiplying by 1 over 4, and this is what it turns into, root 6 divided by 4. Okay, so they are the same. And that brings us to the end. So if you didn't realize this, there are some ones that you can try underneath. They're color-coded, right? Easy, medium, difficult. The answer key is given to you as well. So one of them says to divide. Okay, and you can try some of the harder ones. Specifically, we'll do one here where it says rationalize the denominator. Just because if you think about a B, well, 5 divided by 6 isn't perfect, right? Like, it doesn't simplify nicely. So I'm going to have to get rid of this root sign on the bottom because we don't want to see it on the bottom. So I got to multiply by 1, and that 1 will always come from the bottom. So root 6 and root 6. Every time, always use the bottom radical. So when you actually multiply, you get root 30 on the top divided by the square root of 36. And again, these don't divide perfectly, so we'll leave the root 30 there, but the square root of 36 is 6. And again, you're going to see that number in 3 places. Original question, what you're multiplying by, simplified version. Always the same 3 numbers. Depending on the question. It could be 6, could be 8, could be 7, whatever, right? But it has to be in 3 spots. And now you can simplify the top part, if possible. I don't think there's a perfect square number in root 30, actually, so we're done. Right, so that one step this time to get rid of that root sign on the bottom simplifies it perfectly. Okay, so you'll have the option, I guess, if you want to try some. And if you scroll to the bottom of the document, which you'll find the links to, there are all the solutions to it, right? There's all the answers. right? And there's even b that we did, right? Root 30 over 6. So they're all there. So if you want to try them, you have them. In the next video, we'll start to talk about more of the variable sides of things. And again, a link will be provided to you at the end of this. So hopefully we see you in the next one.